In part A of the question, Mrs. Leggard is running from point A to point B, and then from point B to point D, and we need to know how many calories she will burn. So total, she's running 25 blocks, so this is part A, 25 blocks, and she's burning 9.8 calories per block. And so if we multiply 25 times 9.8, we are going to get 245 calories for part A. For part B gets a little bit more complicated. So in part B, Mrs. Belis now is going to be walking, and she's walking from point A to point C, and then from point C to point D. And we also know from the problem that x, or the distance from B to C, is going to be 9. So the first thing I'm going to want to think about is if B to C is 9, that's going to leave how much here for the total to equal 20. And of course that's going to be 11. So we have the length CD is going to be 11. And then I'm going to need to use the Pythagorean theorem to find out what the length of the hypotenuse of this triangle is. So the Pythagorean theorem, we have a squared plus b squared equals c squared. And in this case, we're looking for the c. We already know the a and the b, so I'm going to substitute in 5 squared plus 9 squared, and remember the 9 is given in the problem. That's going to equal c squared. So we have 25 plus 81. That's going to give us 106. If we take the square root of 106, that's going to give us the hypotenuse, and that is 10.295 or 10.296. So again, that's AC equals 10.296. And so if I combine CD and AC together, I'm going to find the total amount that Miss Belis walked. She walked 21.296 blocks, and she's walking at a rate of 6.5 calories per block. So it's going to be 21.296 times 6.5, and that's going to tell us how many calories she burned. She burned 138.424 calories. Part C asks if Mrs. Belis will walk from point A to C and then from C to D, so she's still walking the same path. We want to write a function c of x for the total number of calories Mrs. Belis will burn on her way to Starbucks. Starbucks, remember, is at point D. Let x be the distance from point B to point C. So this distance is no longer 9 like it was in the previous part of the question. It's now just x. So first I'm going to use what I did in part B to come up with an equation for the distance of each part of this path. So remember, we used the Pythagorean theorem to find the distance from A to C. So again, so this is part C. I'm working with a squared plus b squared equals c squared. A squared can be 5 squared. That's the easy part. But this time, instead of 9, I have just a plain old x squared, and that's going to give me the length of the hypotenuse squared. But I don't need the square of the hypotenuse. I need just to know the length of the hypotenuse. So I'm going to take the square root of both sides to undo the squared. And I'm going to find out that c, or the length of the hypotenuse, is the square root of 5 squared, which is 25, plus x squared. And I can leave it just like that. Another way of writing this is the length AC. So that's going to be the expression for the part that she walks from A to C. And then from D to C, she's walking not 20 blocks, not x blocks, but it's going to be the difference between 20 and x to see what we have left over right here. So that length, CD, is going to be 20 minus x. So altogether for the length that she's going to walk, we have the square root of 25 plus x squared plus 20 minus x. That's the total distance. And we know that she's burning 6.5 calories per block. So if that's the number of blocks, we're going to multiply 6.5 times the total distance that she walked. And that's going to be our function c of x. We don't need to do any simplifying, and the one thing that you absolutely cannot do, that a lot of you are going to be tempted to do, we can't take the square root of this part and the square root of this part separately and call it 5 plus x. That's not going to be a legal math move. You have to leave it as the square root of 25 plus x squared. Okay, continuing to walk you through this problem, on part D, we need to use the function that we wrote to find x, which is the distance from B to C, if Mrs. Belis burns 136.5 calories. So in other words, I'm going to take 136.5 and I'm going to substitute it in right here for c of x. And I'm not actually going to work out this part of the problem. So this is going to become 136.5. And if you remember, if I have a big, fancy, long equation like this, and this is a calculator problem, I'm not going to want to start solving this by hand. I'm going to want to use the calculator. And what I'm going to do is I'm going to graph the left-hand side in either y1 or f1, depending on what calculator you're using. And I'm going to graph the right-hand side in either y2 or f2, depending on the calculator. And I'm looking for the intersection point between the two. The intersection is going to be, it's going to have an x value, and the y value is going to be this 136.5 number. The question is asking us to find x, so that's going to be our answer, is whatever x value we get at the intersection on the calculator. So again, I'm not finishing this problem for you on part D, but that is how you would do that one. I do want to talk a little bit about part E. Part E asks us to find the reasonable domain of the function that we wrote in part C in the context of the problem. So if I'm looking at this function and it's asking for the reasonable domain of c of x, I'm thinking about what values are okay to put in for x in each spot. And reasonable domain usually means go back to the original problem and think about what that original problem is in real life and think about what values x could be. So if I take a look back at my little picture here, and in fact I'm going to make this bigger and move it. If I look at this, x is a distance from B to C right here. And so first thing I'm going to ask myself, because a lot of times reasonable domain, we can exclude some values right away, is the distance between B and C ever going to be able to be negative? And the answer to that question, I think we can all agree, nope, distance is not going to be negative here. So I know that the reasonable domain is going to start at 0. If the distance is 0, I would end up not having the triangle part of this. If x is 0 from B to C, B and C are the exact same point, and I would just have this path right here. Okay, so that's one possibility. It could be 0. The other possibility, or lots of other possibilities exist, x could be very small, and I'd wind up with a little itty-bitty triangle like this. X could be just as it's drawn like this. X could get bigger and it would go like this. But at some point, there's a place where I can no longer get any bigger than the value that I have. And in that case, if I draw my triangle like this, I go from point A to point D right away. And the biggest value that x could be in this case would be if C and D were the same point, and that would give me 20 for the value of x. So our reasonable domain is from 0 to 20 in the context of this problem.